Alright guys, before we get into the video, results back, and yeah, look, I'm happy out. I got a fucking merit. So I got 2 distinctions and 4 merits. Now I kind of knew leaving the exams, I had nothing failed. Like, I was pretty confident coming out, but I don't know, part of me just kind of wanted a distinction because I felt like I put the work in. But I'm happy. I would have bit your arm off at the start of it just to get me a fucking merit. I'll put them on the screen there so you know I'm not lying. I'm happy out anyway, so roll on phase 6. But anyway, just thought I'd let you all know, just fucking, for the people that are here at the start of the journey, I want to just help other people get through phase 4. Right, so we have, where is it? This question: state whether the current is leading or lagging. And you only have this here. So it's not much information, but we have to find the phase angle as well. We start off instantly, find XL, XC, that can stay there, but once we get XL, XC, we can find the impedance. So we'll start off, we should all know the formula. 2, I'm going to do dots because they're the exact same as multiplying. Pi multiplied by F multiplied by L. Now, if you have the formula book, it's all there for you. 2 multiplied by pi multiplied by 50 multiplied by 0.03 XL on the calculator. Hopefully, I don't know if you can ever see this, but 2 multiplied by pi multiplied by 50 multiplied by 0.03. You get pi, bring it to decimals, 9.42 ohms. So we'll throw that in, 9.42 ohms. Now, that's sorted. We have that done and dusted. We have XL. Now we get XC. And you all know the formula. 2 pi F, instead of L, it's C for, well, C. Now, if you don't know how to do this, I have a few videos. I'll link them down below on how to do these. But if you're here and you're asking this question, I assume if you're looking to find the phase angle and whether it's leading or lagging, I assume you already know. So we get stuck in. We got 2 multiplied by pi multiplied by 50 multiplied by 160 microfarads. But because it's microfarads, we have to multiply it by 10 to the power of minus 6. So XC, and you put it into the calculator, we're going to have 2 multiplied by pi multiplied by 50 multiplied by 160 multiplied by 10 to the power of minus 6. That's doesn't seem right. What? What the fuck? Absolute schoolboy error right there. Didn't even do, I just did the XL. But look, we'll leave that in because, look, it happens. You will definitely do that once or twice. 50 multiplied by, do you see this? 160 multiplied by 10 to the power of minus 6. In a fraction. See, I just did basically XL again. We got 19.89. Now, I'm not going to round any of these up because, what was that? 19.89. Yeah. 19.89. Look, if you rounded that to 20 ohms, you're going to get the same marks as what I would get. But this is just going to be more, what's the word? Like, accurate. Like, this is just going to be exactly what we're looking for. So, we have XL, we have XC. Now, we find the impedance. Again, have a video on this down below. It will be linked. So, I'm going to have a lot of videos to link. Anyway. R squared plus XL minus XC in brackets. We square that all to the square root. It's just filling in numbers now. So we have or is 12 ohms. We have 12 squared plus XL, and our XL is 9.42. So we'll put 9.42. XC 19.89. 0.89 squared. all to the square root. Z is equal to, put the square root in, we got 12 squared plus, put the brackets, 9.42 minus 19.89 squared. 15.92. Let me just check to see if it matters if you do 19.89 minus 9.42. So let's just do this exactly again, just to give you peace of mind. We'll go 12 squared plus, I'm going to go 19.89 minus 9.42 brackets squared. As you see, exact same. So it doesn't matter what order you have these in, always going to be the same answer. So what I was always told was just do the higher number minus the 19.89 minus 9.42, like just the biggest minus and the smaller one. It doesn't matter though, you're going to get the same answer each time. Right, so up here we're going to just find the current because it's a small formula. We're going to go V over Z. We're going to go, so 230 over Z, 15.92. Now I is going to be 230 over 15.92, 14.44. I would say that's like the first section of the question done. Now we have R, XL, XC, and we also have the impedance. We are going to find VR, VL, and now VC. So VR, VL, and VC. Now this happens by us multiplying the amps by R, by L, and by C. So for VR, we have I multiplied by R, that is 14.44 multiplied by 12. That gives us should give us 14.44 multiplied by, what was it, or 12. 173.28 volts. 173.28 volts. Now, VL. We have I again multiplied by XL, so 9.42. 9.42. Oh, that's just going to be XL. So we have 14.44 multiplied by 9.42, and that will give us 14.44 multiplied by 9.42, 136.02 volts. VR, VL, now VC equals XC, well no, it's going to be amps first, so I multiplied by VC equals 14.44 multiplied by 19.89 over here. And 19.89. 287.21. Volts. Right guys, I don't have a ruler, but I'm gonna have to make use of the calculator case. Now this is a series circuit, as we know, so we are gonna have VL on top, VC on bottom, and VR, and then we are going to have amps as our inside arrow. This will always be the case in a series circuit. VL will always be on the top and VC will always be on the bottom, and when it's parallel they will swap around. So for VL on top we are going to have 0, 2. VC on the bottom is 287.21. And now VR is 173.288. These are all volts, obviously, so our current is going to be 14. Now, always take these away, VL and VC. It's always going to be, take away the smaller one from the bigger number. The smaller number from the bigger number. So it's, this way, it's going to be VC minus VL. We have 287.21 minus, this is going to be squeezed, but 136.02. It'll be 287.21 minus 136.02. So there we are. 151.19. 151.19. So because this side is bigger, that means our box is going to be on this side. So we're going to have this angle here as 151.19. This VS. Now we have to find the phase angle for this. But before that, we know that this is a capacitive circuit because we have VC bigger than VL. If VL was bigger than VC, it would be an inductive circuit. But it's not, so this is now leading. So if we have civil, we have, because it's a capacitive circuit, we start at C, and that means current leads the voltage. I for current, V for voltage. So current leads the voltage. So we have leading. Right, I've run out of space here, so I'm going to get the phase angle for this page. So the power factor first. In a series circuit, it is R over Z. That is equals to 12 over 15.92. So power factor equals 0.753. Put this in the calculator. We're going to do shift and cos. So it's going to be cos minus 1. So you put in brackets 0.753. I'll show you now. I'm going to go shift cos. So we have the minus 1 in there. This is to get the angle 0.753. Close bracket. 41.14. 0.14. So that's going to be 41 degrees. So the angle here is going to be 41 degrees. Hope that's covered everything. Make sure to let me know if this helped. And yeah, if you want the parallel circuit, let me know down below. Well, to be honest, you're probably going to get that anyway tomorrow. So see you next time.